For the events A and B, probability we read as A given B is the conditional probability of A when the probability of B is known. Thus we have the following result. Probability A given B is the proportion of probability A intersection B over probability B. Since this is coming as a ratio, we can convert our probability to cardinality, like number of elements in the set A intersection B divided by number of elements in the set B or in the event B. Next, the note is events A and B are independent if the probability of A intersection B is same as the product of individual probabilities, like probability A times probability B. Okay, now we have 3 questions we want to answer based on the definition we have above. So the first question is probability B given A, simply probability A intersection B, or you can say B intersection A, they're same, over probability A. Now you can see probability B given A is 0.12. We are looking for probability A intersection B, and probability A is 0.4. So if you multiply both sides by 0.4, you get 0.048 will be the probability of A intersection B. We are done for the first one. Probability E times probability F. So probability E is 0.3 and probability F is 0.4. So when you multiply 0.3, 0.4, we get 0.12, which is the probability of E intersection F. So they are independent. So we are done. We verified this. Now I'm going to question number 3. This is little lengthy. So let me put here A, then I have B, then I put here C, then I have D, then I have a C here, I have a D here. And this idea we are getting because it is telling us that probability C given B. So B is known when I'm looking for probability of C. So that means this portion here is probability A, this portion is probability C given A, and so you can say that this is probability B, this portion is probability D given B. Same way you can say probability C given B, and this one is probability D given A. Alright, so if I have all these, then I can now plug the values. Now first I see probability A is 0.3, so there I have 0.3, and this one I have 0.7. So then altogether it is 1. Now you can see C given A, we do not have, we have C given B. So C given B is 0.4. C given B is 0.4 here. And then we have D given A. So D given A, this probability here is 0.6. Now we can complete everything. Since this one is 0.4, so this must be 0.6. This is 0.6, so this must be 0.4. So our tree diagram is complete. So let me put all together now without those things. So this is 0.6. This one we have got 0.4 in here. So then 0.6 will be here. And this one we had 0.3. And this one is 0.7. All right. So then when I multiply now, conditional probability sense telling me probability C intersection A will be multiply 0.3, 0.4. 0.3 times 0.4. This is 0.12. Then this one is probability probability now, this one will be D given A, but then you can multiply, you can say that A intersection D. So that one will be 0.3 times 0.6 is 0.18. When you multiply this way, you get probability B intersection C, which is 0.7, 0.4, 0.28. Multiply this way, you get probability B intersection D will be 0.42. So we have got all of this. The next part is now probability C. Probability C will be C intersection A and C intersection B. So then we are writing probability C intersection A plus probability C intersection B. So probability C intersection A is 0.12 plus C intersection B is 0.28. Add together, so you get 0.4. That's your probability C. Also, we know that since probability C is 0.4, then probability D must be 0.6. But we want to verify this one from the conditions in here. Probability D will be 0.18 plus B intersection D 0.42. So if you add together, you get 0.6. That exactly we are getting. So next, when you are looking at probability A given C, then this must be probability A intersection C over probability C. Now you can see A intersection C is 0.12 and then probability of C is 0.4 or 40, you can say. This is A given C. Now let us find probability A given D. So A given D will be now A intersection D, I have 0.18 and then D we had 0.60. Probability B given D will be probability B intersection D. So B intersection D is 0.42 and then probability D is 0.6. All right. So we have now all of the information. Let me write now. Now we'll see all this information in our tree diagram. So we are putting all these values. Now probability A is 0.3. Probability B is 0.7. So they are making the partitions in here. C given B is here, which is 0.4. And then we have D given A. So D given A is this 0.6. The 0.6 must be 0.4 here. This is 0.4, so this must be 0.6. So we are done with this left side. Probability C is 0.4. Probability D is 0.6. Now A given C, C is known. A given C is 0.3. So then B given C will be 0.7. Now A given D, we don't know, but we know B given D. So B given D is 0.7. That one will be 0.3. Now this is very interesting. You see that we have started from AB and then condition on CD. Now we have started on CD and we made condition on AB now. So these are the ideas, and whatever we have done in here, this is actually the Bayes theorem, and we are done.